Hey guys, it's Eddie the Magic Monk. In this lesson, we're going to talk about a modeling and problem solving question involving a parabola intersecting with a straight line. So here is the question. The side view of a structure being built at a local park is shown below. So here is a picture of a parabola, and within the parabola there is a triangle. Now on the parabola you're given 3 points. You're given the vertex, the turning point, and you're given the x-intercepts. And the first part of the question, you are to find the equation of the parabola. Once you find the equation of the parabola, then we can go ahead and find the length of the three straight lines. So let's do the equation of the parabola first. Actually, I'll let you guys work it out first. Once you're done, then come back and have a look at how I've worked it out. So the equation of the parabola. Well, we know the equation of the parabola is in the form y equals a bracket x minus b squared plus c, where B and C is the turning point and A is the dilation factor. So we can see in the parabola, we can see in this parabola the turning point is at 0, 20. So that means B must be 0 and C must be 20. So A bracket x minus 0 squared plus 20. So in other words, it's y equals ax squared plus 20, right? Because x minus 0 is just x. So now we've just got to figure out what a is. Now using one of these points, we can say that when x is 10, y is 0. So 0 equals a times 10 squared plus 20. So that means 0 equals 100 a plus 20. So if we rearrange that, we got 100 a equals negative 20, and a equals negative 20 over 100, which is negative 1 over 5. Okay, so now you can try to draw this in your graphics calculator. Y equals negative 1 over 5 bracket, negative 1 over 5 times x squared plus 20, and see if you can get this same graph appearing on your graphics calculator or some sort of graphing program. If you can, then you have found the equation. Okay, now let's do part B. Find the length of the three support beams, so length A, B, and C. So yeah, that is a bit hard, but it's still not that hard. So what do we know about line C is basically it's going up at an angle of 30 degrees to the horizontal. Okay, 30 degrees to the horizontal. Now, therefore, with that information, we can actually find the gradient of this line, can't we? So, if you guys remember, the gradient is equal to, so we're now working on part B. So, let's just go down a bit. So, part B, the gradient is equal to rise over run, isn't it? Now, if I draw a right angle triangle, and I put the angle here is 30, right? And let's say the horizontal line is 1. How do we figure out what the vertical line is? So we figure out the vertical line by using the trigonometry equation. Tangent theta equals opposite over adjacent. So we got tan theta equals, tan 30 equals opposite is x over 1. So x is equal to tan 30. So x is equal to tan 30 times 1, which is 0.57735 and keeps going. So if you guys remember, the gradient is the same thing as rise over run of a straight line. Okay, so if this is our straight line, which I've just shown to you before, right, this is our straight line, then every time we go to the right 1 unit, we go up 0.57735 units. So what that's saying is that the gradient is 0.57735, which is the rise, right? The rise is 0.57735 over 1. So the gradient is 0.57735. So the equation of this line here is actually, y equals 0.57735x. All right, we know that because that's the line, that's the straight line. When it moves to the right 1 unit, it goes up 0.57735 units. So the gradient must be 0.57735. So that's the gradient, and the line is crossing through the origin, so there is no y-intercept. Y-intercept is 0. So using the straight line formula, y equals mx plus c, m must be 0.57735. Okay, now you can draw this on the graphics calculator if you like, but now that we have two lines, okay, now that we have y equals negative 1 over 5 x squared plus 20, and we have y equals 0.57735x, we can work out the intersection of these two lines. Right, we can work out where this point is, where the two lines intersect. So if we want to work that out, I'm going to substitute this where y is in this equation. So I have 0.57735x equals negative 1 over 5x squared plus 20. And then if I rearrange it to put everything on one side, I will have 0 equals negative 1 over 5x squared minus 0.57735x, because I'm moving this to the right of the equal sign, and then plus 20. So now with all this information, I can simply use a quadratic equation solver to tell me what x equals. Right? Or you can use a quadratic formula, so x equals negative b plus minus square root of b squared minus 4ac over 2a. Put this number as a, this number as b, this number as c, right? Put it into the equation and you will get x equals 8.66 or negative 11.547. Now, since we know that x is positive, right, we know that x is on the right hand side here, so it must be the positive answer, which is 8.66. So 8.66 is where the straight line intersects with the parabola. So if that's the case, then what you can do is you can now draw a right angle triangle where the angle at the origin is 30 degrees, and you can figure out that this point here is 8.66. Sorry, what was it? It was 8.66, yeah, 8.66. So the length of this line must be 8.66. So we just need to figure out the length of this line. Let's call it C. So now we use another trigonometric ratio. So since this is the angle, this is the adjacent, this is the hypotenuse, so we use cosine theta equals A over H. Cosine 30 equals 8.66 over C. So C equals 8.66 divided by cosine 30. And then we'll actually get 9.99. 9.99, so I'm just gonna round it up to 10. Just gonna round it up to 10.00 to 2 decimal places. Okay, so C is 10.00. Now, what is the length from this point to this point? Well, since that's 8.66, we can just times that by 2, right? Because that's 8.66 as well, from here to here. And from here to here is 8.66. So 8.66 times by 2 is 17.32 units. And what else did I have? I have A is 17.32 and B and C are both 8.66. Okay, I hope that helps you guys. Thanks for watching. See you next time.